Hi everyone, again welcome to the LPS class. We are continuing our discussion on Python. In the last lecture we saw the regular expression, pretty much like we covered how to do the regular expression. We saw this particular thing basically where we kind of match the string using the R, which is the raw string basically, like then once we have that um, the one the match string, then we substituted the PSI3 with PSI4, and then we explained this concept of this basically. So we went through this section, section. We also talked about some of the additional stuff. So we can use basically can do the search regex with the subject or match regex with the subject as alternative syntax. And the match basically it only looks for the match at the beginning of the line. It does not match the whole string, just the beginning. The search attempts to match throughout the string until it finds a complete match. So that's the difference between the match and the search. We also have this find all. That's another method inside the class RE, and that actually returns an array of all the non-overlapping matches. We can also do like using a for loop here, basically, which is for m in the find iter method basically, and then you can find each one and then until m is basically until you find all of them. So that is same as the find all. And then the matching itself is basically the regular rules apply basically, where we can start the regex with question mark I, question mark s, question mark m instead. So this is something that we saw, and then we also saw the split basically, which is another method in the regular expression class. And here when we do the split, essentially splits on that particular string. So it basically replaces the PSI3 with PSI4. So in this one basically it just splits and then basically removes them. So your output is going to be just this basically upgrade the program to PSI4 was an excellent program. That's all. So today we will continue some more so the discussions on the regular expression, finish off the regular expression, and then move on to the next chapter. So basically the match object function essentially, like so search and match return a match object. The object has some useful functions. Basically you can do group, that is to return the matched string, and then start basically that is the starting position of that match, and then end is the ending position of the match, and then we can also like do a span, which is basically it's a tuple containing the start end positions of the match. So just to understand it more thoroughly, like the Python offers two different primitive operations based on the regular expression. The match checks for the match only at the beginning that we saw, and the search basically searches for the whole thing, and both of them returns a match object. Here are some match object examples. So we declare or we define one of the variables line as the string, and then we say match string search for PSI3 in line, and then so basically the match starts at character. We can say match string start master this particular variable start dot start, and that gives basically like uh, where it starts the match, which is the PSI3, and then where it ends, and then before the match, before match, and after match. Basically, that is with you can specify the index and then start, and then all the way up to the end. Basically, start.end. So this will give you like this section. So the first one will say T3, and then essentially like from 3 next to all the way up to the end, and then here it will start from here and ends up here. So now let's talk about the capture groups. So this is useful to actually apply certain after obtaining a match, take that match and then use it in the as a next variable to do some processing. So we did this for both Perl and Tcl. So the parentheses inside the regular expression denote a capture group, which can be accessed by the number or by name to get the matching essentially of the capture text. So we can name the capture groups with this kind of syntax where we can say like question mark P and then the name, and then we can also take advantage of the triple quoted strings, which are multiple lines. If you remember, we talked about that, to define the regular expression, and that can include comments as well. And if you use this particular method, which is verbose method, that option, and you can use that. So let's look at some examples here. So again, we define an in file where we open this test.txt with a read only, and then we define all the lines basically like where we read the lines, and this is the method for the reading the lines for the in file, and then we close that particular file. Now we use the triple quoted string essentially like so we want to restring. So we start with the triple quoted string, basically like some optional white space in the beginning, and then we say basically so okay now question mark P key, and then followed by any of the things. So any word that begins with P, we match that here, and then we again have like equal sign with some optional white spaces. So wherever there is some equal sign there, and then finally like the non-space after the equals to is the value basically. So we match the key and we match the value, and they are stored in the key and then the value. So here, as we saw here, basically the P name. So assume that you have like xy equal to 3, b equal to 4, c equal to 5, something like that in this particular test.txt file. So now we have the thing before the equal to is the key, and then thing after the equal to is the value. So this becomes an array that you can store as a key value pair. Then we do the restring ignore case essentially like then then pipe it to the verbose basically, and then that's what we are compiling, and then we do like the for line in the lines. So print key equal to the match group key, and then value is match group value. So this again prints basically xy and then 3, and then it continues on B 4 C 5. So that's what we want to get basically. So in other words, actually, like now this is as an array basically. You can think of this as restring xy key equal to 3. This is what we are storing essentially. So now let's move on to the next topic, which is the collection data types. So here we will talk about tuples, the lists and dictionaries essentially. So tuples are collections of collection of data items. They may be of different types, and usually tuples are immutable, just like strings that we saw basically. Like I mean the lists are like tuples, but they are mutable. So there is a difference between a list and a tuple. So Python uses this parenthesis to denote a tuple. You could also use the parenthesis if you have just one, you have only one item. But if you have one, sorry, if you have only one item, then we need to use a comma to indicate a tuple. So here we have like 3 names, so we just put comma and then put it in tuple. Whereas if you have just one name, we just put the name, then followed by comma, and then put it inside the parenthesis. And then the empty tuple is denoted by just empty parenthesis. We need to enclose a tuple in a parenthesis if you want to pass it all together as one argument to a function. So this is, you can think of in tuple, we had this basically like notation where we pass the entire thing as this one object. So some of the other things that you want to know about tuples are also like iterable, meaning like you can iterate one by one. And the anything like, I mean, that's pretty much it basically on the tuple. Now the lists essentially, lists are like tuples. The only difference is that they are mutable. That means that you can actually change that data structure, and they are denoted by square brackets instead of the parenthesis. So here we have like 1, 3, 5, 7, 11, and that's denoted as a list. And then you can also have different values, basically 0, 1, boom is also a list. An empty list is just square brackets stuck together. And so the mutable property is described here. Basically, you can add elements to the list, or basically you can append an item. Here we define a particular list 1, 2, 3, and if you want to append done to it, we use the method xappend done, and then that prints out with that. Both lists and tuples contain object references. So the list and tuples are also objects. They can be nested. So you can actually describe a tuple within a list, and a list within a tuple, and tuple within a tuple, and list within a list. So here we can say basically, so A equal to 0, 1, 2, B is A 3, 4, and when we print A, it basically a nested list is getting printed. If you print B 0, 1, it prints 1. So if you print B 1, 0, basically that results in an error. So the 0, 1 is this object. So B 0, if you just print B 0, that is 0, 1, 2, and B 1 is 3. So B 0, 1 is actually this object, which is 1, whereas B 0, 0 is just 0. Okay. So some more examples of lists. So this is like a list example of pi. We define one list, which is just the odd number except odd numbers except 9, and we print x. Now when we print x2, and can anyone tell me like what is this one? This is actually like, now it's 5. X2 is 5. Now we do this operation, which is we are doing an assignment x2 equal to 0. Now what do you think, will this replacement happen? It happens in list because lists are mutable, so you can actually change them. So we will replace 5 with 0 with when we assign this one, and then if you print out x, it prints like 1, 3, 0, 7, 11, and then we can apply x append, the method append to it with number 13, which just adds 13 at the end, and everything in square brackets. Okay, and then if you remove 1, this removes 1, and it is not the item at position 1, it just removes 1 item. So the remove 1 basically maybe removing the first item. The position 1 is actually number 3, so this is the first item just gets removed. and then we after that we insert at the first position, we insert number 42. So this now the insert actually takes this as the positional thing. So for that it starts from 0, 1, 2. So the 1 position it is going to insert 42. So your overall list is going to be like 3, 42, then 0, 7. So the 0 is pushed and then it gets inserted there. I want you to remember this thing. The remove one doesn't mean that the first position gets removed, but the insert one means that the insertion happens at the first position. Okay. Now let's look at some of the indexing. So the indexing, we know that actually it starts from 0, 1, 2, 3, and 4. So in this case, if the x2 is actually 5, that is because it's counting from left to right. It's 0, 1, and 2. And then when we do an assignment with x2 equal to 0, since it is a mutable, it basically now changes that, and then so that the 5 is replaced with 0. So the difference between again the list and the tuple that we saw is while the indexing of a tuple also works exactly the same way. I mean, it starts from 0, 1, 2, 3, 4. You cannot do this operation because the tuple is an immutable data structure. So you want to do that. And then slices is another one. Slices work as for strings basically. Like so, if you remember, in a string like I mean string, we can specify a slice of ran, which is like starting from 2, 3, 4, 2:4. That's the string. Those are still apply with the lists. So here we can specify like I mean it's 2:4, and then that is like 0, 1, 2, 2, 4. So 2 and 3 will be printed out. So here it's basically RN is 2:5. And now we can this additional operator, which is basically the incremental operator that we saw basically. So here we have a list 1, 3, 5. So we can use the method a dot append. This is one way to do it, and then we say 7, and then that gets added at the end. We can also do just simply a equal to plus, and then the square brackets 7, and then this will add that element into that list. But if you try just a plus equal to just regular 7, this is a failed case because you need to specify the 7 inside the list file for it to be added to the existing list. So when we do this, the result is 1, 3, 5, and 7. And then we can also add anything basically. So we say like the end, add the end into the list. So again we use the same thing, and then now if you print a, it's 1, 3, 5, 7, and then the string the hyphen end. So this is another shortcut operator that you can use it instead of the append function. Now let's look at the dictionaries. The dictionaries are nothing but items are. It's an unordered collection where items are accessed by a key and not by the position in the list. So a dictionary is just like a hash in Perl. The collections of arbitrary objects and you can use object references like lists. And then dictionaries are also nestable. We can grow and shrink in place just like list, and it allows concatenation, slicing, and other operations that depend on order of the elements. So they depend on the order of the elements, do not work on dictionary. So all these concatenation, slicing, and operations which depend on the order of elements, they do not work in dictionaries. So let's look at some examples of a dictionary. So here in this example, create like jobs, basically David, professor, Sahan, postdoc, Sean, grad student. So these are the three elements that we define inside the dictionary, and you notice that actually each of them is basically it's a keyword followed by a colon and then another keyword and then a comma. So anything before colon is your key, and then the other side is the value. So if you just say jobs Sahan, it gives you postdoc. And then this is also a mutable database. So essentially you can just say like jobs Sean equal to postdoc, and then you can change the job of Sean also to a postdoc. And then if you want to list of keys and values, we use this basically like this method keys. So for jobs dot keys, basically it prints the 3 keys. And if you notice, basically like the order actually it's changed. Originally our order was David, Sahan, and Sean. Now the new order is Sahan, Sean, and David. And then values generate again the corresponding values in the thing. So this is another method that you want to remember. And then once you specify the values, you get postdoc, postdoc, and professor, which are professors of in profession of or the jobs of these people. To query like every element, which is like a key and the value together, we use the items function. So the jobs.items function returns Sahan postdoc, Sean postdoc, David professor. So that's how you can access those values in the list in the dictionary. So the key thing that you want to remember is it starts with the curly braces, ends with a curly brace, that is the dictionary, and then the items the each key is separated from its value by this colon, and then the each items are separated by commas essentially. So that's what here, and then the whole thing is enclosed within the curly braces. So the empty dictionary, you can create it by just putting empty curly braces. So here only thing is even though we said that basically like this is a mutable type of database, the keys are of immutable database in data type. So keys are immutable. They should be one of either string, number, or a tuple. These are the only data types allowed as the key. The value can be anything else. So because the value itself is not immutable, it's actually immutable. So now let's look at some of the common operations that we can do in a dictionary. So we can delete an entry by just using DAL followed by D and then the key name. Then if you want to add an entry, then we just basically say the new key is the new value. If you want to find out if particular key is in the dictionary, we can use the ASCII function, ASCII key name or key name in D. Basically, this is another thing that you can see. The get is a method that is useful to return value, but it does not fail basically, so it returns none if the keys does not exist. So you can use the get to get the one, but if it won't fail basically the key doesn't exist. So that is only caveat. So the way to use it is the get and then the key value and then the default. Update merges one dictionary with another, and then this overwrites the values with the same key. So the usage is like the update D2, and then we give the dictionary version of concatenation. So now if you want to iterate a dictionary through the keys, we can use the for command. So here actually like we can specify like Gone with the Wind and Margaret Mitchell, Aeneid, Virgil and Odyssey by Homer, and then we do the for book in book authors. So it knows that the key is actually like going to be the book, and then we basically book authors book basically. So it gets each one and then it adds the by and then basically prints the whole thing. So wherever like when we specify a variable, that always iterates on the key. So as you can see, like actually key is the most important item in a dictionary. So the properties for the of dictionary keys, essentially the values themselves have no restrictions. They can be any arbitrary Python object, either standard objects or user defined objects. But there are two important things that you want to remember. One is more than one entry per key is allowed. So if you have so when a duplicate key is encountered during an assignment, the last assignment always wins. So a simple example will be define a dictionary. Dict equals, again, the three things that you want to define in dictionary are enclosed within curly braces, and then put the key, say name, and then put the colon essentially, and then say Zara, and then comma. Correct. So this forms one element, and then age, again colon, and then Sarah, and then another comma, and then finally again we call it name, colon, num. This also encloses. We need to close the parenthesis. So now in this particular dictionary, if you want to print dict in square brackets name, and this will always be Manny. The Zara name is gone, only retains man, because that's what its last updated value is. So if it cannot be hashed, it just overwrites it, overwrites the previous value or with the new value. Now constructing dictionaries from lists. So for this we can use the zip function. So if there are two separate lists for keys and values, we can combine them into a dictionary using the zip function and the dict constructor. So that we have a dict constructor and a zip function. So the way to use is basically we define the keys, we define the values, and then the dictionary variable equal to dict zip keys with values. So some general keys instruction, basically, like, so keys don't have to be strings, it can be any value that we already saw. It's only its immutable data type, including tuples. This particular property is good for representing sparse matrices. So here there is a matrix which is just a blank dictionary, and then we populate essentially one value 101 with 0.5. So the key is tuple. You can see that basically it's enclosed within the parenthesis, and then 114 is another one which is 0.8. So to represent this, basically it's good that you don't have the string or any other data type. Now collection length essentially is computed using the len variable that returns the length of a tuple, list, or a dictionary. that is like how many number of characters of a string. So len Tony with this parenthesis, because this is a tuple and we are looking for the length of the tuple, it returns 1. But if you do a length of just Tony without the tuple, now it returns 4. And length of a list essentially, which is 0 1 boom, is 3. So let me talk about some of the built-in operators, dictionary functions and methods within the thing. So len is one of them. The other one is CMP. CMP, basically the usage is dict1 and dict2. So this method actually uses CMP. Basically it compares these two dictionaries and then sees whether they are the same or different. We can also have a str dict, which is a conversion from the dictionary to string. And then there is also a type variable. This returns the type of the passed variable. If the passed variable is a dictionary, it will define, or it will return a dictionary type. Now Python also supports several other methods. One is dict clear. This clears all the elements in the dictionary, essentially dict. And then copy is another one, which makes a shallow copy of the dictionary itself. And then the dictionary from keys is another object that creates a new dictionary with keys from the old dictionary, and then it sets the values to 0. No, sorry, the set the values to the value itself. So the usage is just dict, not from keys. And then the from keys has the parenthesis as well. And then there is also a dict key with the default none. This returns the key, and then it returns a value or a default if the key is not in the dictionary. And then dict has key actually returns true if the key in the dictionary is dict is found. And dict items, essentially it returns a collection of dicts, key value tuple pair. Dict standard faulty is another one, which is similar to the get, but it so the dict has key returns true if the key is in the dictionary dict, or returns false. And then we have items, update, dict values. There are several methods that are available. Now let's talk about the is operator. The Python variables are really like object references. This is something that we saw. The is operator checks to see if the references referred to by the same the same object, are they like actually like referenced by the same object or not. Here we can have two identical objects which are not the same object actually try to access the other location. And then the references to the integer constants should be identical. So the reference to strings may or may not show up in the top as referring to the same object. Two identical mutable objects are not necessarily the same object. So let's look at an example, some examples of if operator. So here we define two of them and then print x is y, then it is true here, but it's not necessary. 1, 2, this one is false because it's a list. And then in a tuple again, if you ask print x is y, it's also false even though it is identical and immutable. And then x is equal to the square bracket basically where x is none, true. Now we talk about an in operator. In operator is for the collection data type again. The in operator determines whether something is a member of a collection or not. So this is what we used for like some value whether that is part of the program or not. So we use that. So here an example, basically like team we define as 3 people, and then we say like whether Howell is in the team, and then it says false, and then um, Stuart not in a team. So the keywords are here basically. Then it becomes true. To traverse the collection data type, we have to use the we can use the in essentially for something in something. So the something in something is defined here. Basically, like numbers are defined as 1, 2, 3, and then we can say like for I in numbers. So basically, it takes those things and then print that I. So here we get 1, 2, and 3. So now, how do we copy collections? Essentially, like I mean, we can actually if you use an assignment, it just makes a new reference to the same collection. So here basically like we just say it's a list B equal to A, C equal to A colon A square bracket and then this column, and then if say B equal to 1 and C equal to 1, and then we say like then ask to print the A, B, and C. So then now essentially like it prints 053, 053, and 073. And we can copy the dictionary with the copy function. So essentially it's basically a column copy. Now there are a lot of other methods essentially like for the this variable essentially. So some of them are, one is clear, which removes all elements of the dictionary or dictionary, whichever dictionary that you specify. The copy that we saw basically it's returns a shallow copy of the dictionary. From keys we saw already, like how that is set, and then get key default none, which gets all the keys, and then hash key returns the value basically of the key, returns true if the key is in the dictionary, else it is false. And then the item that we saw, keys we saw, and then we can also do a set default where we can which is very similar to the get or db copy, sorry, db get or the get parenthesis function. And update is essentially, we saw that is updates the key value pair, and then values actually gives the dictionary of the dictionary's values. So let's stop at this point today, and then we will go into the advanced functions in the next class.